Hello friends, welcome to this CSIR NET Newtonian Mechanics Syllabus Tips and Strategies class. In this class, I'll be talking a lot. I'll be showing you what kind of problems usually asked in Newtonian Mechanics, and I will give you tips that were from to study and how do you study. So let's start. I divide this Newtonian Mechanics all syllabus by 4 parts. The first, the most basic, is elementary mechanics. Usually one question, this one is number of question asked in general per CSIR NET. So in general, one question from elementary mechanics will be always there. Second part is integration of conservative systems, plus I added small oscillation here itself because both this have a very common important property that we are dealing with conservative systems. So this part you accept 1 or 2 questions. Second is rotational plus rigid body plus non-inertial, which is a huge part, 1 or 2 questions. Minimum 1, maximum 2. Central force, which is also a big deal. So you get either 1 or 2 questions. So let's go to more detail. Elementary mechanics. This is class 12 part, H.C. Verma part, H.C. Verma level of mechanics. But you guys also miss this part questions a lot. So okay, let's hear a little bit about the elementary mechanics. So what topics are in the elementary mechanics? We have Newton's laws, free body diagram, tension, frictions, etc. We have equation of motion solving problem, which is differential equation, impact momentum, conservation of momentum, work energy theorem, center of mass collisions. These are class 12 level. Okay, so you have to, if you are weak in this part, you have to do H.C. Verma. So no escape from there. So okay, let's start. I just skip this free body diagram, tension, friction part. You already know this, I guess. If you don't, then go to H.C. Verma. And usually the CSIR NET does not have that elementary level of problem, but CSIR NET have this problem, Newton's law problem by differential equation, by solving differential equation. This dissipative force problems, I'll show you examples. You have solved examples everywhere. You can find Spigel theoretical mechanics. In Kleppner also you'll find lots of examples. I'll show you 1-2 examples from CSIR NET. So this is CSIR NET December 2016 problem. It's a simple dissipative force problem with a damping force minus gamma v. So the ball is dropped from a tall building. I think you can get this. So it's nothing. The m dv dt is the force, the mass into acceleration part, which will be mg minus gamma v. So you need to solve it. This is an initial value problem. So at 0 initial velocity, it is told. So you can solve this type of problems. So this usually sometimes asked in CSIR NET. There is another type of problem which is minus gamma v square. So it is a easy problem, so it is not tough. Same thing, minus gamma v square. So you just have this equation, you have this equation, you will solve it. You try it, right? So the basic problems from momentum, energy, collisions, these are also asked. Let's have a simple example. So here it's a plain class 12 problem. A ball of mass is dropped from a height. The coefficient of restitution is told, and how much length the ball will rise in the second time. So I think you will do this. AC Verma level of problem. This is a very basic problem, collision problem. If you are stuck with any problem, you may pause the video and attempt. So this is a very common problem from class 12. So collision problems, momentum problems, sometimes they ask. June 2019 also. This is very simple. I'm not doing this. You just attempt it. It is a five minutes at most you take in each problems. So these kind of problems people ask. See, this is very common. June 2019, December 2019, coefficient of restitution bouncing back type of problems. June 2017. So this problem has an extra feature, so just be careful with it. The answer is not answer is not for n. Be a little bit careful on this. So okay, these are class 12 problems. So let's start with something new. So these are integration of conservative systems problem. Where from I will study. I already uploaded a dimension and analysis advanced class. You guys didn't watch it, I guess. So if you have not, then please do watch. You'll get this type of problem solved. Not all, but one special type of conservative system equation, one special technique you'll learn there. And I will make a separate class later, don't worry. So this type of problems are there. One-dimensional problem, potential Vx is alpha x to the power 6. If the total energy of the particle, the time period in a periodic motion is proportional to. You just get a formula, but the essential thing is you need to do an integration. Half of m v square or x dot square plus vx is E. So this is E is conservative, E is constant, total energy is constant. So from here you do an integration. So this is dx dt, it's E minus Vx multiplied by 2 by m. So from here you can see that dt is your dx. E is a constant. So 2 by m or m by 2 you can have an integration. So start from here. The next part is solved my dimension and analysis. This integration, you can find it. Now this is 2 class 2, which is advanced class. Okay, so you can see that these type of problems are very common. June 2018, June 2019. So you just do carefully, solve it, and let me know whether you are getting on it or not. Okay, the next part is small oscillation in 1D. The theory you'll get in Kleppner, chapter 5. In almost every net, you will get one question which are asked from small oscillation in 1D. So like this, all the problems have a one basic structure. So they're given a potential. Here the potential is ax minus bx cube. And here the minimum velocity that has to be imparted to the particle to render its motion unstable. So it is not a frequency finding problem. It's a minimum velocity that where is the top of the potential? Where is the top? Say, if you have a potential like this, so here if is V min and here if is V max, so you need to give this much of energy, right? To make the particle out of the potential. So you can find this. This is not tough. Another type of problem, this is very common problem. So finding frequency of oscillation. You'll be given a potential. Sometimes the potential looks like this, sometimes the potential looks like this, sometimes the potential may look something else also. So if you are given this type of potential, you should find the frequency of oscillation. You need to do a Taylor series, theory in Kleppner. Find the theory in Kleppner, chapter 5, I guess. You need to do a Taylor series here. Okay. This type of problem also comes. This is a central force problem. And in central force, just dealing with this is not enough. Small oscillation problem, perturbing something in a central force potential. Here also the perturbing something in a normal potential. And here it's a central force potential. So in central force, your system is in 2 dimension. So you must work with V effective, not with this. And what is V effective? V effective, you know, right? So deal with this, work with this. The other procedure is same. In December 2023, the latest, no, not latest, just before latest, this problem is very, very simple. You are given a Vx. This is exactly same as this type are same. The potential becomes changing, keep changing day by day. So this type of problem, you can expect one problem in your CSIR NET and you will get 3.5 marks, or sometimes 5 marks also, part C also. You might be asked. So don't leave this, please. Rigid body dynamics is a very high weightage thing. In general, we can expect one question, definitely one question, sometimes maybe 2 questions. So we divide this as easy and tough, or easy or advanced problem. The easy problems in rigid body dynamics, we are dealing with rigid body. So rigid body dynamics easy problems are from higher secondary levels. Verma and Kleppner's are enough. An example, uniform cylinder, uniform sphere released on an inclined plane, then the speed of cylinder when it reaches the bottom, blah, blah, blah. Class 12, Verma examples, you can find it. So these are Verma level problems, I have written this. So this type of problems, sometimes they ask cylinder rolling, mass rolling, something, you are rolling, I am rolling. So this type of simple, this is a planar motion of rigid body, not a space motion of rigid body. Rigid body advanced problems are also there. So we go to tougher problems, let's say B.Sc and M.Sc level problem. There are lots of things to do here. Kleppner, Upadhyay, Goldstein, step by step you go. For example, it's a very simple definition of rigid body. What is the degrees of freedom in rigid body? 6. Okay, in 3 dimension. What will be in d dimension? N into n plus 1 by 2. This is d into d plus 1 by 2. You need to know, every good book write this. Yeah, so sometimes it is written somewhere. So you need to go through the textbook. Okay. This is moment of inertia tensor calculation problem. Sometimes they ask MOI tensor. So this is this you need to learn. No ways. These are point masses, so it will be easy to calculate. Sometimes continuous masses can be also asked, but never ever in CSIR NET they ask you something which are very big calculation type of problems. They don't ask because they know how much maximum time a student can afford in a problem. So your concept should be okay, but calculation should be small in the exam. And whenever if you are dealing with something which are getting a very huge calculation, inside the problem. So you must understand that you are doing something wrong. So, okay. This is relatively new problem. Rotation axis and rotation angle. This problem can be thought as mathematical physics problem, also can be thought as a classical mechanics problem. How to find rotation axis and rotation angle? Generalize, Euler angle type of thing, right? Think about it. This is a general matrix. Lipnar, Goldstein, rotation axis and rotation angle. This is also a moment of inertia problem, like that. Time period appreciation. Exact formula, if you don't know, you cannot do, but advanced rigid body. Symmetrical top. This is advanced. Euler equation. Symmetrical top. First do a Upadhyay example, then come back. Okay guys, these kind of problems they ask. This is also, you can see, uniform circular disk. If the disk set in rotation about the origin with an angular velocity, this the direction of angular momentum. It's a direction of angular momentum problem. So your L is actually starting from rigid body. You must know L as a vector, I as a tensor, omega as a vector. So start here. This is also a Goldstein example, actually Goldstein exercise. This problem actually can be found in Goldstein exercise. Upadhyay example. I forgot exactly example or exercise. I write both as EX. So this is not that tough. If you are missing, please let me know that you are unable to do it. But it can be found here. It can be found done by very basic definition itself. Very new problem, the test problem, June 2024. Similar kind. Uniform plane square sheet, which is rotating. Let's say sheet is rotating. Angular momentum is given and where angular velocity is. So here also you need to start with the same thing. This problem and this problem are similar. Very similar. You start with here. You need to find this. You need to get this. Not a one-line problem, but sometimes it may get a little bit tough. This problem is relatively easy. I0 is already told. So do it. Not tough. Non-inertial frame has lower weightage. Sometimes one question may be expected. Coriolis force, centrifugal force problem. So this is one problem. Attempt it. This is another problem you can attempt. This is another problem you can attempt. Not every CSIR net. Say 2-3 CSIR nets, they skip it, then once again they ask it. The whole thing comes under that rigid body. Non-inertial problem also, I am classifying this under rigid body. Okay. You can read Goldstein. Otherwise, you are free to Upadhyay is fine with this. How much time I've got? Okay, quick. Lastly, central force problems. Central force has highest weightage in CSIR net Newtonian part, because it both comes under Newtonian mechanics part as well as analytical mechanics, which is generally I tell Lagrangian and Hamiltonian part. So both type of problems are there. So at least one question, sometimes 2-3 questions. So you will study central force in both way, initially in pure Newtonian way and later in Goldstein way. Upadhyay also discuss central force after they introduce Goldstein Lagrangian part. So you do it in both way. First, they are very easy problems. These are simple formula based. So you remember that at least one question, 2 or 3 questions also I have seen from central force. So if you are strong in central force, you are strong to qualify CSIR NET. Okay, nice. So say the radius, this is class 12. Height, if you differ height by 1%, how much G will change. I have told you earlier that CSIR NET syllabus is from class 11 to M.Sc second year. Okay, so here also class 12 problem. Acceleration in Earth. What will be the acceleration of gravity in Mars? So this is easy. This is slightly, not exactly class 12, but angular momentum conservation. In any central force, you see that angular momentums are conserved. And in circular orbit, angular momentum is MPR in circular orbit, right? And L is constant in central force. Apply those ideas, you'll get it. Not tough. If v is the half of the escape velocity, then what will be the h by r? You may always pause, right? I'll be telling you, I'll going through quickly. This is also class 12. So okay, so those are very easy problems. Very easy problems. Here are moderate or I'll also tell you easy problems. A little bit of workout is necessary. Klepner and Upadhyay will be sufficient in this part. These are circular orbit problems. Any central force which are not a Kepler's problem, means which are not inverse square law, which not following inverse square law, but some other law, but a circular orbit. In any circular orbit, you know the potential will be a minimum. So you do this, just formula. Klepner, J.C. Upadhyay, just have an idea that circular orbit. What is a circular orbit? Always mv square by r should balance any force. So read something about circular orbits available in any books. No issues. Binary star, slightly problematic, but not that tough. You can always work it out. Okay. This is also a similar thing. Circular orbit. Whenever you see a circular orbit, you get that idea. mv square by r should balance the force. So whatever potential is given, you find force from there and do this. Not tough. This is no calculation was required to do this problem. Without any calculation. Without any calculation and any formula. Just a common sense. Calculation of formula. Just common sense. Apply some common senses here. You'll do it. Okay, discuss among yourselves. Relatively new problem, but simple problem. Just very simple. Simple information about elliptical trajectory. Everything is done by where? Everything is done in Kleppner. You'll get it, no issues. Very new problem. Particle is in inverse square law. This is gravitational force. Type of force is there. Force changes suddenly. What's that? Quickly here, the shape of the new orbit would be. Think about what are the things will be conserved here. If the force changes suddenly to this, some things we know do change. Sorry, some things do not change, but some things do. What will not change? Remember this dialogue. Some things do not change, but some things do. Matrix, part 2. Movie Matrix, Matrix trilogy. Part 2 or 3? 2. So this is relatively tougher problems, not very tough, okay. Stable circular orbit. We have a formula. We have a ready-made formula, so you'll find that formula in books. Only Kleppner Upadhyay is sufficient. We have a ready-made. Okay, guys, tough problems. You may skip these tough problems for now, but central force do have some tough problems. They do ask. Mangalyaan problem. Hofmann transfer is called. This is Earth to Mars problem. The problem does not looks very tough, but is not that tough, but still tough. So this is called Hofmann transfer. You won't find it except Kleppner and Goldstein. Kleppner do cover this Hofmann transfer. Other books also cover it. So this, find something about Hofmann transfer. This is also Thornton Marion's book also deal with this. I'm definitely writing the spelling wrong. Okay. If you Google it, Google will correct your spelling. This is also a slightly tough problem. So we have some tough problems from central force. So this is Goldstein exercise problem. This is also Goldstein type problem, not Goldstein exercise, but if you do some Goldstein exercise, you can do this. This is also this problem have in Goldstein. Goldstein deal with this, but you first learn it from here. So these are tougher problem of central force. So that's it, guys. That's what I planned to discuss with you. So I think you got a good idea about what kind of problems may be asked in CSIR NET in Newtonian Mechanics part, and I have shown you the examples and told you the strategies. You start with this. You start from very basics of Newtonian Mechanics. So thank you very much, and feel free to ask anything to me and discuss among yourselves also. Thank you once again.